Hi, welcome back to another video. This is about my umpteenth attempt at drawing a bloody circle, but we'll hope we get it right this time. So, equations of a circle. Alright, we get our lovely little equation here. It's a bunch of letters, and barely any numbers, and it doesn't make any sense if you just stare at it, right? But I'm just going to try to teach how this equation actually came about, and hopefully it gives a bit more understanding, and I'll maybe do one practice question as well, just to show how we can actually utilize the knowledge. So let's say we have a point, this little dot here, and we call it HK, like Hong Kong. Easy to remember. So HK is our little dot, and we draw, this is not a circle, right? Not because it's badly shaped, but because it's not actually what it is really. This is a set of points on a graph that all are r distance away from the middle, right? And it just happens to make the shape that we call a circle. So all it's saying is this pink line that goes around this midpoint is all r distance away perfectly. So you could rotate this line anywhere, which I'm not going to demonstrate because my drawing's probably not very good again, which I've tried about 10 times. So just trust me, in theory, it should be the exact distance away no matter where you put that line from the middle point, right? So, perfect. Now, how do we actually work out what that distance is? Well, we've just said this is a set of points, right? So we'll define one of these points. So we'll say up here, this is x, y. All right? Just a very general point. Now, if we know that that's x and y, then what we can actually figure out is this vertical height from one point to in line with the midpoint, and this horizontal height, horizontal length rather, from the midpoint out. And this over here is 90 degrees. So we just draw that. So this horizontal length, to start off with, if this is x up here, and this is h over here, right, we're going straight down in line with the x value. So this x value is the exact same, right? The y will be different. I'll just draw a squiggly line, but the x value is the same as this one up here, right? Because we've gone straight down. We haven't gone across at all. So what we can define this distance as is x minus h, right? Because if you go x is here, and you go across to h, that's x minus h distance. For example, let's say x equals 3, h equals 1, 3 minus 1 equals 2, and if you think 1, 2, 3 on a number line, you have to hop twice to get to 1, right? So that difference there is the distance that you're traveling. So that's why x minus h is that distance, and we can apply that exact same theory very conveniently. I keep trying to zoom in here. What I should actually be doing is just make this bigger. Lovely. Okay, there we go. So we should apply this exact same theory to this over here. If that's x minus h, then this will be y minus k. Perfect, because this y value is the only thing changing across this entire journey down here. The x value is staying the same because you're going straight down. Perfect. So now, how do we work out r from this? Well, r, if we use Pythagoras theorem, because it's a 90-degree triangle, right, is, I'm just going to use colors here. If this is our red side, and this is our green side, then green, red, I love highlighters, if you can't tell. Green, squared, plus red squared equals orange squared, right? Now we just have to fill in the blanks. Green would be x minus h squared plus y minus k squared equals r squared. And this looks remarkably similar. In fact, it looks the exact same to this equation up here, right? These are actually perfectly equivalent to each other, albeit the horrible drawings.